Good afternoon, everyone. This is Alan Badeau. We'll start here in a quick moment. I see some folks are still joining, so we'll give it about 1 more minute before we go ahead and get started. All right, let's go ahead and get this kicked off. Good afternoon. My name is Alan Badeau. I am the CTO for NCI, and today we're going to be talking about how we are empowering our customers with AI application modernization. And we're going to talk about a variety of different things in this presentation. And critical to this is our strategic relationships with our technology partners, of course, Holonic Technologies, who is bringing Codeintent to our solution, and I'm going to talk more about that, as well as our internal development efforts associated with driving enterprise brains and application reuse across our entire software factory. So before we get started, though, I do want to encourage everybody. Let's do a little bit of housekeeping. So I want folks to be as interactive as possible, and you can see that there is a Q&A portion up on top in the menu bar. Please feel free to type in questions. When I see those, I will try to answer those. And if I don't get to those, then we can save some of them for last. I want this to be as interactive as possible, and make sure that if there are any questions, I can hone in on different pieces of the slide to make sure that the folks online are getting as much out of this as possible. The first thing, though, I do want to start with a poll, and I encourage everybody to participate in these polls, just from a fun perspective, and to break it up. So the first poll is going to be around how many of you have customers that have varying legacy applications that are 15 years old. So you can see that it popped up in the window. Please click an answer. I'll wait about 15 seconds for you, and you'll hear some uncomfortable radio silence, and then we'll see what the results are. So go ahead and please vote if you can. All right, and let's see what some of the results are associated with those polls. So 96% of people have customers that are supporting legacy, software applications, which is not surprising. It's been very evident, of course, from the COVID-19 results, especially with different states and some of the systems that they have. I heard one of the older ones was actually about 50 years old, and it hasn't gone through a modernization in about 25 years. So those are the challenges that we're facing. So please keep that in mind as we move forward. What I want to do is, let's go to the next slide. Let me talk about NCI really quick, so you can understand the journey that we have been undertaking over the past few years. So we are a 30-year-old system integrator. And the beauty of that is our customer relationships that we have been very proven, and we've worked with our customers over the year to drive innovation into their environments. I came on board at NCI as the CTO about 3.5 years ago, and my goal was to drive artificial intelligence, into those customer spaces. And it's been a journey, to say the least. And we faced an interesting decision very early on whether or not we were going to build it ourselves or, of course, go out and partner to bring some of those technologies to our customers a lot faster. And we chose the second route, which gave us the ability to take, the best and some of the newest technologies in AI, work with a partner that is willing to work with us and drive through, the various requirements and getting those technologies and tools into the government space. And then at the end of the day, the customer can benefit from that. And, at the same time, though, over the past year, we have started to supplement some of those efforts with our partners. So we're developing additional tools on top of theirs so that we can really maximize what the benefit is and stay at the bleeding edge of those. So I already mentioned, of course, our strategic partnership with Holonic Technologies and their Codeintent tool that they have. We're going to talk about that a lot today. We also have, of course, a strategic partnership with a company called Tanjo, and they are the creators of the enterprise brain, as well as some animated personas that we're deploying in our customer spaces. And we're going to focus on those tools and what we are developing along, with those technologies, so we can drive what our AI-driven software factory is going to look like. And then we're going to walk through a demo as well to support those. One of our proudest moments came, late last year with our win of the joint service provider contract, where we are actively deploying a variety of different machine learning capabilities, chatbots, neural nets, those sort of things, as well as our work with the UK government in deploying neural nets, into their spaces as well. So we've been actively supporting, those customers. If we go to the next slide, what I want to do is briefly talk about our Empower platform. So, what it is, it's an open architecture platform, and really the goal is to quickly deploy AI solutions. And within those capabilities, our overarching goal is to accelerate what our workforce can do. We want to take things that computers are good at, let them do those things while allowing us to repurpose, our human capital to focus on higher priority activities. At the end of the day, that's really the only way that we can, maintain, funding profiles, that we can make sure that our staff is fulfilled in their, daily work lives, as well as, improving the overarching customer experience. Because at the end of the day, if the customer doesn't like it, then you have not been successful. And our Empower platform, just launched about 2 weeks ago, is something that we're very proud of, and you'll hear more about that later on. We break it out into what we call empowerment. So those are specific AI tools and capabilities that, allow us to optimize what our workforce is doing, such as, intelligent automation with customized bots that are developed from neural nets, as well as the code modernization, capabilities of our Holonic CodeIntent tool sets, that we're using as, as part of that team. And then lastly, looking at being able to deploy machine learning in a variety of different areas, whether it's, augmenting a service desk, or, replacing different functions of, a cybersecurity, monitor, so they can go do other development activities. It's those sort of things that we're trying to do. From an Empower Me perspective, that's really our centralized hub where folks can go gather and pull from a variety of different tool sets that are already developed. This way we don't have to reinvent the wheel all of the time. And then finally, around our Empower Evolve perspective, which gives us, the ability to use AI to monitor our AI deployments, because we want to stay ahead of, our deployments, to make sure that we are monitoring real-time, issues that could pop up, performance awareness, or just as data drift, happens, then a variety of times we have to move on the fly to make sure that our neural nets are going to behave the way that we expect them to. So one of the empowerments that we're going to talk about today, of course, is our AI application development. We're going to focus on, a couple of different examples towards the bottom where we are, looking at the modernization piece. And we've talked a little bit about intelligent automation and machine learning and where we are deploying those actively today. But our main focus is around the modernization using our AI toolkits as well as our partners tool, Holonic's CodeIntent, capability. And I am excited today, though, to say that we have just started a project at the Executive Office of the President as well, and we are going to modernize some of their applications, within their technology stack. So let's go ahead and jump right into the toolkits. So why do we want to refactor, and what are some of the constraints that we're seeing? So generally, the popular one is that the customer experience is awful. They're using a GUI that doesn't work. It's, in some cases they still have green screens. They have no ability to innovate and take new technology and augment what they currently have. The support is just too darn costly. I've seen some statistics that say that you're paying COBOL programmers in some cases $300 to $400 an hour to support some of these legacy applications. And in many cases, they may be the only person, still supporting, those types of programs that has any experience with those code bases. Pony Express speed to deployment. That's one of my favorite ones. Customers expect an iPhone type experience where they can go out, they can enter the marketplace, and they can pull down the applications that they want. They don't like the fact that it takes them 4, 5, 6 years to have their application modernized to something that's going to be more user friendly. Of course, an ability to maintain an ATO, as the requirements change, and the mandates change. In some cases, it's just not possible to maintain that ATO. And then, of course, they can't handle volume and surges in users or users of the systems that we've seen recently. And then, of course, no one can sustain it. We've had some customers where we have been provided applications, and we have found out that there are really only 5 people left alive that had any understanding of what is inside that black box. And in one case, 4 of them had left the government space and were supporting commercial customers. And that meant there was only one person still as a contractor that could assist in that. So that's a problem. And so when you look at, of course, what those real-time constraints look like of these systems, they tie very nicely, unfortunately, back to the why we want to refactor. And when you look at managing the technology debt, when you look at the inability to optimize a deployment inside of the cloud, it can't scale, it's monolithic. Those sort of things are just driving costs. And every time you see one of these, then the dollar figure just keeps changing. So it's important that we tackle these in a systematic and proven way. So what's the modernization conundrum? So if I gave you all a statistic that, and I don't think anybody would be surprised at this, that a recent survey by Princeton University found that 98% of colleges and universities inside the United States are no longer teaching legacy applications. I don't think anybody would be surprised about that. The most used programming languages, according to Statistica, and this is a recent 2020 poll, are the languages shown here. This is great if you've got a new application, and for instance, a lot of the folks on my team are developing in these languages for some of our AI deployments that are sitting on top of these legacy systems, and so that's fantastic. But the challenge is most of our government customers are still using COBOL, Fortran, Pascal, and Ada. And these statistics have been pulled from a variety of resources. but you can see the scale and the challenge associated with that. You know, OMB estimates that there's still 350 billion lines of code today used in government. That's a significant hurdle and significant challenge, especially when you look at some of those customer spaces where they're being used, whether it's the DoD and mission critical systems, all the way to, you know, some of the weather models that are used to support the Commerce Department. Those are significant challenges that we have. And as we start to back that down to Fortran, which I do love Fortran, that was my language that I wrote my dissertation in, you know, so it's still very close to my heart. But, you know, it's not what we consider a modernized language. When we hire, you know, new developers coming out of college, and we say, you know what, we want you to take a look at this Fortran code and figure out how you can help us modernize it, they don't get really excited about that. And that's a challenge for us. And so, you know, how can we allow those new folks that we're hiring to focus on development instead of focusing on fixing somebody else's code that, you know, they have no interest in. So that's where our, you know, a scaling humans perspective comes into play, and how we can drive some of those things. And clearly these two things just don't align. Somebody that's programming in Go, as I said earlier, is not going to be excited when they have to go figure out COBOL and the myriad of variables and how those are defined in a usually unfriendly manner. So we're going to talk about that. So let's talk about where we're starting the process with our teammate Holonic and their Codeintent toolkit. What I want to do is give everybody a basic understanding of the how and what its goal really is. And so we capture business intent, code integrity, policies, orchestrations, the true intent of what the developer had in mind when he actually was writing the program, and allow AI to understand that and use deterministic principles to convert it to a pure mathematical form. So this picture is sort of like a general ConOps for folks to be able to see what the basic premise of that is. So we'll start with, you know, standard operating procedures, user manuals, new requirements in some cases. And, you know, if we have to allow the AI to watch how a program behaves, and that creates what we call the knowledge subsystem, right? And, you know, this is the more, of course, the more information that we have, the better the AI is going to be able to perform. And then as well, you can see our friend Yoda down in the bottom left-hand corner. That's really your application guru who understands the language, understands some of the heuristics around what the program is trying to do. And if we can glean any kind of information from that, then we can add that to you know, our knowledge base. And then the next piece of that is that ties then into our AI inference machine. And a lot of times, you know, you can see it called a variety of different things, an AI engine, a system engine, you know, those sort of things. But that's really where Holonic and their Codeintent, you know, package really excels. I'm not going to get into any of the proprietary nature of exactly how they do that, but it's one of those technologies that has really been able to crack the nut, you know, over the last few years, and has been used in the banking sector for you know, a variety of years, and they have been successful on doing those sort of things. What we do then is we can take any legacy application, and we allow the AI to ingest that, and based on its understanding of the previous language, you know, the understanding of the legacy language, it can then go through and say, you know what, I understand what this code is trying to do. Or if it has any sort of questions, it will, you know, ask for some support, and it will say, I don't understand this. Please help me learn what I need to know so I can understand, you know, the entire intent of the code. And as we're going through that process, you know, as the AI raises its hand, then a human will interact with the system, and it'll say, well, what it really means is this, and our folks will write a small amount of code to teach it something. It'll point to something it has already seen in other legacy legacy applications. It'll point to a different area of the code where it did understand that. But it's really around a SME supplying those facts to make sure that we get 100% intent coverage. And once we go through that, then it's converted into what we call the intent space. And then from the intent space, we can do a variety of different things with the application. We can re-platform it to a new system. We can optimize what the current application looks like, or we can refactor it into a modernized language that's going to be a lot easier from a support perspective. Now, you can see that I didn't specifically talk about new application development or new requirements. One of the nice things about this system is that once the AI understands what the language is, then we can write feature documents that can be fed into the AI, and the AI can also automatically generate code from those features. So we can do model-based system engineering, which looks at sysml and converting that to code. We can do a lot of different things to support that. Now, one of the nice things is of course, Obi-Wan is a SME who is working with the AI to provide some of that intent, but we're not talking a significant amount of time. We're only talking about maybe a few hours a week to go through certain legacy codes, and I'll talk about an example later on so folks can understand that. But it's a young Anakin user that can also work in the presentation interface from new development capabilities, as well as taking some of these tool sets that our partner Holonic can create, and then applying those to other different applications. So let's take a quick poll on slide 10 about the understanding of what I just said. So can we launch the poll for slide 10, please? All right, let's see what the results look like. Yes, 81% of you understand the intent space. That's fantastic. So for the other 19%, just from a quick principle, the intent space is its purest mathematical form. So we convert it using canonical mathematics and transformations and transforms and matrices that will make your head hurt, which is why the AI is highly suited for handling a multidimensional space. And at the end of the day, that allows us to really prescribe the entire code set in its purest mathematical form. And once we have it in that complete mathematical form, then we can re-platform it to any other system as we need to. So I hope that the further explanation helped with that. All right, so what's our AI digital developer look like? So when you think about the entire DevSecOps, and Agile teams and what those processes look like, what we want to do is we want to augment, or in some cases replace, what the developers are doing, especially around a refactoring problem where, as I stated before, developers don't want to work on somebody else's code. They want to develop. They want to work on things that are their own. And so this is where we can really scale what a developer's performance is. So we can take the as-is code, and we allow the Holonic Codeintent tool to ingest that. It does its a code assessment of that, and then it parses the code to see if it has any questions associated with that, as well as analyzing what those features are. After it has done that and decomposed it, then of course, as I said earlier, we're focusing on the deterministic nature of the AI. And one thing that's very important, and this is what makes Holonic's Codeintent tool so different than what's out there today. It's not based on syntax, and so it's not using natural language processing to do a translation of what somebody else has written. It's using our Holonic's proprietary methodologies to ingest it, as well as to look at the semantics associated with the code. And that gives us a leg up over any other tool that's out there, because we can do it a heck of a lot faster with this. And we also are not guessing. Natural language processing has some sort of probabilistic mathematical routines that it's using, and your only confidence level is going to be that you set. And so in this case, the AI is either knows it or it doesn't know it. If it doesn't know it, it raises its hand and asks the human trainer for assistance. If it does know it, it moves on to the next one. So after we've iterated, we get into the intent space. And at the same time, one of the other unique features of about this is that we can provide hardware, software, vulnerability assessments. It doesn't matter if it's a weapons system or a back office application. The AI looks at all of these applications the same way, and so it'll go through those. It'll create different sorts of dialogue associated with this piece of the code is not up to industry standards, and I cannot recreate that. Or in one case, for example, with a Power Builder tool set, there was SQL injection that was a possibility in the Power Builder code, and the AI identified that and said, I will not create this same sort of issue when I convert over to Java or to .NET. Then we go into the validation phase, of course, and from that validation phase, then we can harden it, we can containerize it, we can recompose it to any new language or platform. And then as well, and this is something that folks that are used to filling out forms for ATOs and for commenting codes, the AI can do a heck of a job in providing all that documentation associated with those codes. And so it will generate a majority of the ATO package. Now, of course, it's not 100% by any stretch of the imagination. We're not there yet, but the AI will facilitate that process, and that allows us to cut down the time to those by about 60%. So that's something that is very beneficial. And then, of course, we can use your standard tools for version control, of course. And then one of the other things that we're going to talk about here in a moment is our AI common source marketplace brain. What we can do is we can take our machine learning capabilities and allow it to ingest the code that Holonic's Codeintent has generated. And once it's in there, then it creates a common source library where new developers can ask the brain which application is most appropriate to provide a radar system, and where can I start, and the AI will point them in the right direction, or it can also just give them the code so they can start analyzing it. So with speed and scalability comes a significant challenge on the back end. If the AI is generating a significant amount of code as part of the development process, then we also want to make sure that humans can process all of that information, and we just don't provide them something where they have to go search and they have to do all the work to get any kind of information around that. It's just one more way that we're accelerating the capabilities. And then, of course, from a metrics perspective, we can tune the performance of the codes based on what the SLAs are. We can get customer feedback on how the GUIs look, what those are presented, and then we can automatically incorporate that feedback into the AI, and then we can run through that again. That is a standard process for us. This is standardized across the board, and it really allows us to accelerate the time to delivery. So if you think about what your typical application development projects are on a code that's 5 million lines of COBOL, we've all have familiarity with those programs that are taking 5, 6, 7 years, depending on, losing the backlog, trying some other automated tool sets that get them to about 80%, and they can't rectify the last 20%. They can't sustain the code, they can't read it, and then there are challenges that just fall out from that. We have solved that problem, and Holonic's CodeIntent tool is the forefront of our ability to do that, tied with our AI common source marketplace brain. Does anybody have any questions on this slide? I don't see any questions yet. Boy, I like it when I must be on my game today if I'm hitting all your questions. That's great. So we are going to go to let's go to the next slide. Oh, okay, wait a minute. Let me go back really quick. There was a question on let's see, there is a question that says, so does it consider variable, method, and class names when determining intent? It does. It looks at all of those activities. One of the things though that we generally do not do is allow the AI to look at the comments associated with the code. And the reason is those comments are usually dated. In some cases, the comments have absolutely nothing to do with what the code is actually trying to do. And so as it's going through and assessing what the intent is, associated with that, it will generate those features, and then we'll be able to support those as we move forward. That's a good question. Thank you. So let me quickly talk about our AI common source marketplace brain. As I said earlier, what we're trying to do is drive the management and interaction of the AI, the Holonic CodeIntent developed code, so that it's seamless for the user or for new developers. We really believe in program once, use many times, and the only way that you can provide code at your fingertips is to have somebody or something that is facilitating that. And there's no better tool to use than our AI capabilities and the marketplace brain. What we're doing is enhancing the common development environments across the entire software stack. We're providing a common capability, a perspective from the greater user community, so they can go grab things a lot quicker and pull that into what their development environments look like. It's providing a single set of specifications and how it's managed. So configuration management, of course, is key. But we want to also be able to monitor what goes out into production. And the only way that you can really do that for very large, programs that have a multitude of codes is to have the AI do that. Now, we could do that with humans, but it doesn't make sense from that perspective, from a speed to delivery perspective. So if somebody wants access to a piece of code, and you have to have a human that becomes part of that loop, then by nature you are slowing down the loop. We wanna put humans on top of the loop so we can speed through the entire process. And at the same time, that gives us the ability to provide a reusable set of processes and metrics, while making sure that third-party developers can facilitate and participate in this process. Now, what you can see on the right-hand side is of course, Holonic CodeIntent and the software that they're developing as part of that piece of the process. But also that maybe customers don't want to refactor some of their other applications. So we also ingest those into our brain, so the brain understands what those are doing at the same time. Now, on the bottom right, you can see where there's a rating scale. There's, has the AI provided me what I was looking for? And is it relevant? Is it not relevant? Is it speed? How long did it take to do that? And so there's a rating system that is embedded in there. So users will be able to see based on what their searches are, how it's performing and what some of the best applications are going to be. And then of course our ability to interact with that knowledge brain is going to be so important, because being able to get that code at a lot faster at your fingertips is really what is driving that. Let's see. So I do have a couple of questions. Let's see. Let's look at let's see. So Holonic Codeintent translates old code to math form that AI can translate to modern code. Is that a good way to understand it? Yes, it is a very good way to understand it. The math associated with that is, we make it sound very easy when we say that, but I can promise you it is not. And this is something that Holonic has spent many years perfecting, and is significantly ahead of any competitor out there. So that's a great question. How about, let's see, another question is, how about code security with Holonic? So that's a great question also. When we look at the AI ingesting the code, of course it's going to, it's going to state or outline any of the vulnerabilities that is in the current code base. Now, what's nice is it's not going to generate new security flaws. And so I gave the example about SQL injection that you routinely see in Power Builder. It would not generate the same issue when it went to Java, just because it understands that's a big no-no and it won't do that. It can also, depending on what the cycle looks like and how we are running, Holonic's Codeintent, we can, even after we have developed, the new version of the code, we can routinely rerun Holonic's Codeintent, so it can re-ingest any code that humans have developed, continue to identify any vulnerabilities associated with that new tool set, and then rectify them as we would want. Let's see, another question. Once Holonic Codeintent completes a refactoring effort, can it apply what it has done to another job? Yes, the beauty about the Holonic Codeintent software is that it can either start from ground zero, meaning it takes us about 2 weeks to train it on a new language, which is of course vital to some customers who of course will not allow you to bring anything in or take anything out. If we have the ability, then of course, if we have 100 COBOL codes that we want to refactor, then of course, once it learns the first COBOL code, it's going to apply it to the second one, and it's going to apply it to the third one, and continue on down the line until it gets smarter on each of those codes, which I won't say creates an easy button way after you get to about code 20, but it does make the training time significantly less than what it would take normal humans to do it. Just to give you some time scales, generally industry best practices say that it takes anywhere from 9 to 12 months to train humans, Agile teams, on what a legacy code is actually doing, so they can completely understand what the code is doing, how it's performing, and what it's looking at. We can do it in 9 to 12 days, in some cases significantly faster. And so that's just a baseline speed of understanding that the Holonic Codeintent toolkit can deliver to our customers. Let's see, and let me take one more question. What is the primary benefit of using Holonic Codeintent to refactor a modern code like C++? That's a great question. We see that a lot, but there are significant benefits to that. So for instance, say you have 10 million lines of C, you have multiple development teams that are supporting that. How do you know that each of your developers is what you would consider an A developer? You don't. you know, a lot of times, you know, people just by nature have different ways that they write code. You know, a lot of it either comes from what their training is, what their expertise is, you know, those sort of things. And what Codeintent can actually do is it can still ingest that out, you know, that C++ application, but it can tell you what the problems are with that C++ application. But then it can also generate an optimized code set inside of C++ that then can be further sustained by your you know, C++ application developers. So there is you know, an ability to provide that that reassurance that you've got the best code that is, you know, I almost said humanly possible, that is AI possible, and then you can drive those. Now also on the back end, say for instance, you've refactored your C++ code using Codeintent, and now you want to add new features to it. Well, instead of having to add more Agile teams to support those activities, we can address the backlog significantly faster as well. And that's just another added feature associated with that. So let's talk about our AI-enabled software factory. And, you know, at the end of the day, what we're trying to do is integrate, you know, as many AI tool sets as we can, so that we can, you know, ensure transparency in our, you know, things that we're generating and the code that we're generating, as well as, you know, ensuring security and, you know, really speed to delivery of these sort of, you know, capabilities. So we leverage our scaling humans with AI and process engineering framework to develop requirements and drive those requirements. We also use, of course, standard tool sets such as Jira and Jira Service Desk to manage those. Then you know, you see where the typical Agile teams and developers would be located. That's supplemented by of course, the Holonic Codeintent you know, capabilities. Now, again, we still have you know, some developers that may support the activities. We have, of course, cloud engineers that can support that. But to give you an example, if you have 10 to you know, 12 Agile development teams that are 8 to 10 people, usually it would take us 3 or 4 Agile development teams of, you know, 3 to 5 people to support the same thing. That's the power of this methodology. Of course, you know, we still we're leveraging Tanzu and their products internally, but you know, from our perspective, OpenShift, we can overlay this with OpenShift, and we see no issues or performance degradation associated with how we're delivering it. We just need to know what our customers are using to monitor and get into and manage the CI/CD pipeline, and then the releases associated with that. And then, of course, at the end, we're generating that common source marketplace that allows us to create that user interaction associated with that support. Let me take a quick drink really quick. Those of you online that can see me, it looks like I'm drinking invisible Tang, but it is real Tang. So I do love the background effects associated with this. So one of the things that I want to focus on is that the software factory is more than just, you know, simple refactoring. The tool sets that we're providing with, of course, you know, the Holonic Codeintent tool set, as well as the enterprise brain, really allows us to not only scale, but it allows us to do a variety of other things. So such as greenfield development, as I mentioned earlier, by you know, converting SysML to code and then back, new feature generation where, you know, we're writing sort of the scaffolding that the AI ingests, and then the AI can generate code to support that, and then really simultaneous development. Now, we haven't talked very much about that, but it's something that that we're doing, because, you know, as the AI is analyzing code, you know, it's telling, you know, what the vulnerabilities are and the issues associated with that. Now, imagine that you're doing pair programming but instead of having a senior developer and a junior developer working together, you have any developer that's working with the AI. Specifically working with the Holonic Codeintent tool. And what that allows you to do is anything that you're developing, the AI is going to scan and it's going to tell you whether or not it's up to snuff or whether it's not very good. And so, at the same time, you can see how that rapid interaction between those capabilities can help from a training perspective. And it's something that we're really excited about. The enhanced resiliency and the hardening piece, we can take any code, black box, runtimes, executables, and we can allow the AI to ingest those, monitor them, and understand what the heck is going on in those tool packages. As I mentioned earlier, being able to consistently monitor how developers are interfacing with a new Codeintent generated code base is really important, because you don't want to have to start the process all over because you've turned it over to humans, and after a year they've put so much into it, so much bloat into it, then we wind up having to refactor again. So we like to do a scan, usually at least once a month, and if we can do it more times, then that's even better, and we can combine that pair programming capability with making sure that the code stays modern, sustainable, and up to date. Of course, the ATO generation we talked about a little bit earlier, so that's really important. And then the last piece is around wargaming. And so think about it from this perspective: that if you have malware that you have received and you want to be able to do a quick analysis about that, we can feed that application into Codeintent, of course, in a environment that it's not going to get out, and Codeintent will go in and it can identify what some of those key feature sets are going to look like. And as you build on what that technology base is, of course, then you can start to do fingerprint analysis associated with the code, meaning, okay, this threat is very similar to a threat that I've seen in another location or another code. And at the same time, that gives you an enhanced capability to do analysis around that. And then, of course, the last piece is around adaptive modeling and simulation, and being able to do some of these activities to support tactical edge devices and some of the key components of those systems in near real time. Now, of course, we're not there yet, but that's something that we're actively working toward being able to do. So one of the questions that I see is, what value comes from looking at variables, etc., names from old languages with 8-character limits on the names? That's a great question. There's not a lot of value that comes from that, but what it does is it just feeds into the entire understanding of what the code is trying to do. So you have to think about it this way: if you're going line by line or syntax, then of course you can see where you can quickly get off the rails by trying to look at these 8-character names and the limits associated with them. When Codeintent is going through its process and it's trying to understand that intent, then any information that's relevant, that's used in a different place, is going to provide that knowledge base that's going to be important for us to be able to successfully get it to the 100% intent space. Let's see. How does Holonic Codeintent report something inconsistent in the code? So remember, it's knowledge base and it's standard operating procedures and the information that it's been able to attain. If it sees that something falls outside of that that window, then it's going to be able to say, you know what, this is not up to what I understand is industry best practices or the standard operating procedures that I have seen. Now, at the same time, it can, because it's looking at a syntactical level, it can say, you know what, this piece of code has been developed by somebody else, because it's clearly not using the same variable type definition. It's not you know, up to the standard operating procedures and the requirements that I have, you know, ingested in my knowledge base. And so it can identify those inconsistencies fairly easily. And, you know, that also ties into the vulnerability discussion that I mentioned earlier. So just really quick, I'm not going to talk too much about this. We've got about 10 minutes left. I do want to get to the demonstration really fast. Generally speaking, you know, from a cost perspective, you know, it's usually how many Agile teams you got with humans in it, and how long is it going to take? What we can see is that even compared to traditional translation tools that use the 80-20 rule set, we're at least 50% cheaper than what our competitors are able to do, and you know, significantly more effective from a time perspective. We're talking 3 to 6 months, and in some cases 6 to 12 months for very large complex codes. An example that we recently worked with Holonic in the Codeintent tool set. We were given 24 million lines of COBOL, and because it already understood COBOL, it only took it 6 days to understand what the intent of the code was, as well as generate on its own 365, you know, about 365 of the green screens that the code was doing. Now, we never compiled the code. We didn't do anything with it. This was the AI being able to ascertain what the code was doing. So you can see the power of what we can do from a system perspective. Now let's get to an example really quick. So from, you know, of course, you know, we recently received 1.7 million lines of COBOL. The assessment piece took about 2 days. The parsing piece took about, you know, 2 days. And of course, there was a Thanksgiving holiday that was thrown in there, which put us a little bit, I won't say behind, but of course it allowed us to take the day off. And then to parse it, it was another 1 day effort associated with that. And then after 5 days total, the AI had completed 100% of the parsing of the code. That is, you know, think about how many Agile teams and how long something like that will take. That should by itself tell you what the speed is of this. Now, as we started to look at the refactoring, you can see what, you know, in this case, another green screen, you know, effort associated with the decomposition. This is where the AI is regenerated what that green screen can look like. And, you know, you can see that the user interface, of course, is not that pretty, but it's also passed and, you know, given us an understanding of some of the logic errors associated with that, security vulnerabilities, and some of the bugs. And this is the nice thing is that it's a web interface where you can drill down into either the errors or the bugs associated with the code, and you'll be able to see those features that, of course, the AI wasn't very pleased with, and then make sure that they're addressed on the back end. That's a great piece of the Holonic, you know, tool set that you know, facilitates that process much more smoother than traditional methods. And then, of course, the refactoring piece, you know, it really takes us about another 12 weeks to refactor what those, you know, into that new language. And in this case, it was going to be into C++. I want to show you a quick example of a Power Builder code where, you know, we had a customer, they had about only 100,000 lines of Power Builder. The challenge is Power Builder is a COTS tool. It's not open source. And so we allowed the AI to ingest all of the SOPs associated with Power Builder, but come to find out, you know, go figure, that the documentation that was provided doesn't align to, you know, necessarily how the application is performing. Nobody's ever seen that before, right? You know, so then we also allowed the AI to watch how Power Builder was performing certain routines, and then we could go through the entire process. Now, one of the things that's unique about this as well is that, you know, we had Power Builder developers that were supporting, the application, and they wanted it over to a Java platform. Most Power Builder programmers don't necessarily know, Java. And so the challenge is how do we make not only the user experience similar to what they had, but also make sure that the code is going to be sustainable after we leave. And so we took the Power Builder code, converted it to Java, and then the structure of the code was very similar. So then the on-site team only had to really learn Java. They didn't have to relearn the new structure of what the Java code looked like. And again, that goes back to our pair programming discussion and how we can optimize that. One of the things that you want to make sure, and why we have SMEs involved in the process, as I showed earlier with Obi-Wan and in some cases Yoda, you don't want to turn the code over to us and just tell us blindly refactor it, because what's going to happen is the AI is going to optimize it to the point where more than likely it's not going to have the same kind of GUI that you would want your users to have. It's going to be in the code base is going to be, in such a way that it's fully optimized, and it may not be as sustainable as you want. And so we work with the SMEs to make sure that we're telling the AI, put it in this format, make it look this way, behave this way, just from a perspective on, making sure that at the end of the day, the customer is satisfied with how it looks, how it feels, how the user is going to act with it, and how it performs. Now, I have this graphic in here because I know many of you on the call have experienced the same sort of issues. What do we happen when we deviate from the baseline? We either reset what the baseline looks like, or we add more people to supplement what that process is going to look like, so we can handle the backlog a lot more efficient and get closer to the baseline. What usually that means is that that's increased cost associated with the contract, or it's increased time associated with how long you had provided in that baseline. So that's where the creep starts to come into play, and as you are resetting what that baseline looks like, you start to lose what the original goal of the program was from a timing and a feature perspective. In our case, using the Holonic CodeIntent tool set as well as our enterprise brains, then we add more CPUs to the job if we need to. Generally, we don't. We just have to make sure that it has the ability to crunch through it. The humans never touch the code. They're only teaching the AI things that it does not understand. So you can see where that process is. The AI might not have understood something. A human will teach it. The AI reruns it, might not understand it. And that iterative loop, though, for us to do that is significantly faster than any AI teams, from a performance perspective. And if it's faster, it's also going to be significantly cheaper. And at the end of the day, that's what we're trying to show. And lastly, what I'd like to do is talk about our empower and evolve capabilities. And so what we're trying to do is we're always going to be monitoring what our backlog looks like. We're going to be monitoring interactions with the brain, all of these as a service to make sure that we're watching 24/7, we're providing the right analysis, and we're driving that optimization out to our customers. And just to show you and really a teaser into one of our next discussions, probably next month, it's going to be around how we can, leverage AI to drive AI, and what that entire process is going to look like and how we manage that. And again, this is based on another commercial partnership that we have with a company that is doing something very similar to this sort of thing today. So with that, I want to thank everybody for their time. We're at 1:59. I want to thank our partners, of course, Holonic Technologies and their CodeIntent toolkit, as well as Tanjo and their enterprise brain, and the NCI team, who are developing capabilities to help augment these tools so that we can drive them to our customers and really optimize what services that we're providing to them today. These are things that we're deploying in real time. We get about 100 inquiries about these capabilities, our AI capabilities, a week. And so I encourage you, though, if you do have any questions, please reach out to me. You can send me an email, or you can call my mobile number, and I'd be happy to of course talk to you and see how we can help support you all in some of the initiatives that you have with your customers. So thank you, and that's, I think, where we are ready to stop. Everybody have a nice day.